Okay, welcome back. Here we are, Unit 2-4, Unit 2-4, and let's get moving here. So just a reminder, if you see any of these, here's your icons here. Okay, watch only, put into your notebook, and write down those practice problems. Standard 2.0 is still where we're at. We'll move on to 10.0 here pretty soon. Today we're going to learn to use division properties of exponents to simplify expressions. In the previous unit lesson, we talked about multiplication properties. Now we're going to look at division properties. Division with exponents. So take a look at this. A to the 7th, b to the 4th, over a cubed b to the 5th. So if we broke that down into little teeny pieces with bases and exponents and all that, we'd end up with a whole bunch of letters A, a whole bunch of letters B there, top and bottom. And now what can we do when we have integers or any real number in the numerator and a denominator? Well, I'm pretty sure you remember we can cancel them out. So if we cancel out some A's here and here and here, what else can we cancel? How about a letter B there, and letters B there, and so on. And what we end up with is what's the remaining. And so what's remaining, look at the numerator. How many A's in the numerator? 4. How many letters B in the denominator? 1. And of course, if you look kind of carefully here, 7 subtract 3 is, of course, 4. And B to the 4th over B to the 5th, well, if you started canceling, you'd end up with 1 letter on the bottom there, and that's where we get B to the 1st. Alright, so let's practice this real fast. You've got m to the 3rd, y to the 5th, over m squared, b to the 3rd, y to the 3rd. So what can cancel here? It looks like the letters m can cancel, and the y's can cancel. Not the letter b, though. The b has no one to work with, so we're going to leave him alone. But if we just string them out and start canceling, we end up with those guys go away, and there's some m's that get canceled, and some y's move out. And what are we left with? Well, it looks like 1m, 2 y's, and 3 letters b at the bottom. And there's your final result, my squared over b to the 3rd. So take a look at these. How about n to the 6th over n to the 4th? Well, the bases match, so what can we do with our top and bottom? Well, let's just subtract them. So we end up with n to the 2nd. How about this one? m to the 5th, y to the 6th over m to the 4th, y squared. And we're going to end up with my to the 4th. My to the 4th. Okay, a little bit messier here with this one. We've got a squared b to the 4th c squared over a squared b cubed. So why don't you try that on your own for a second. Looks like the a's are going to cancel. Looks like most of the letters b are going to cancel. So did you end up with b c to the 2nd power? B to the 1st, c to the 2nd. bc squared. How about this one? 15x to the 5th over 15x squared. Let's deal with the numbers first. What's 15 over 15? Well, that's just the number 1. So those 15s can cancel. And now, go ahead and subtract x to the 5th over x squared is x cubed. X cubed. Alright, why don't you watch this first one here. Now, if we're dealing with fractions and exponents, it's going to be the same business. 2/3 to the 2nd power. So we know that that's simply going to be 2/3 times 2/3. Or we can apply our exponent rule and just have 2 to the 2nd over 3 to the 2nd. Which would get us to the following 4/9. Okay? So you try this one on your own. 1/2 to the 2nd power. 1/2 is in parentheses, so we're raised to the 2nd power. So how about, I'll give you a second there to move ahead. How about the following? 1 squared over 2 squared. What's 1 squared? 1 times 1 is 1. 2 times 2 is 4. So you should end up with 1/4 as your final result. 1/4 if you started there with 1/2 squared. Okay, consider this. What do you think would happen if the exponent we were multiplying by was negative instead of positive? So think about that for a second. So instead of multiplying by, let's say, a positive 2 as an exponent, our exponent is going to be negative 2. What might happen there? If you multiply by a negative exponent, this creates what we call an inverse relationship. In other words, the numerator becomes the denominator, and the denominator will become the numerator. We'll see an example of that here. So, watch only on this one. If we have some generic problem that says b over a to the negative 2, so we can distribute the negative exponents, but in the answer we want these exponents to be positive. So when you see negative exponents, just think about maybe some people complaining. People complaining here. So when you take a look at the following, we end up with this negative 2 distributed top and bottom. You get b to the negative 2 over a to the negative 2. So when you see these things, instead of going through any complicated mess, just consider, what if these people were just unhappy where they were? Well, in a fraction, you can be in the numerator or the denominator. It's only 2 places you can be. So if you're unhappy being in the numerator, then by default, if you were in the denominator, you'd be satisfied. So let's go ahead and just consider taking these two here and reversing them. You can also think, let's say you have two kids sharing a bunk bed. If they're both complaining that they're at the wrong spot, then just have them switch top and bottom, and they'll stop complaining. Well, at least we hope. So if you switch those two, your final result is the letter B goes to the bottom, the letter A goes to the top, and you end up with A to the second over B to the second. And high school teacher's happy because you're using positive exponents here. A squared over B squared. So see where we started and see where we ended up because of the negative exponent. All right, try this one here on your own. You've got x over y, that's in parentheses, to the negative third. And remember, we want positive exponents in our answer. So go ahead and press pause if you need to. I'm going to delay here for a second and then move forward. I'm going to take that negative 3 and I'm going to apply it to the top and the bottom. So notice I've got x to the negative 3 over y to the negative 3. And now both of these guys are unhappy where they're at. So because of the negative exponent, I'm simply going to change their position. So we'll make x move to the denominator and y move to the numerator. Don't have to worry about changing the number of the exponents. That's exactly what all we do here is just switch spots. So it's y cubed over x cubed. And you're done. Alright, so try this distributing this negative exponent. You've got 2x over y cubed, and all that's grouped into parentheses, to the negative 3. So what do you think? This negative 3 is going to apply to the 2, to the x, and to the y cubed. So here's what I'm going to do. I'm just going to put that negative 3 on everything. Okay? So the 2 to the negative 3, x to the negative 3, y cubed to the negative 3, and yes, we definitely have some complainers here. Okay? Everyone's unhappy. 2 doesn't want to be in the numerator, x doesn't want to be in the numerator, y doesn't want to be in the denominator. So what can we do? Well, if they're unhappy where they are, have them switch top and bottom. So now you get a positive 9 as an exponent and the positive 3. Right here, 2 to the third power. The reason this isn't done is I think we can simplify 2 to the third. So what is 2 to the third? That's 2 times 2 times 2. You should end up with, this is your final result, y to the 9th over 8x cubed. Y to the 9th over 8x cubed. So you kind of see how we started. We applied the negative. Everyone's unhappy where they're at. Switch the places and simplify. Okay, how about this one? So let's take a look here. You've got x squared over x to the negative 1, y to the negative 3. So here's a hint for you. Only move the unhappy pieces. So if you look at the bottom, it's obvious this guy's unhappy at the bottom. He's unhappy at the bottom too. What about this x squared? Well, the x squared has a positive 2 there, so let's leave that one alone. So we're only going to move the unhappy ones. So we'll just simply move them to the top. Let's combine like terms. If you have x squared and x to the first, that's a pretty simple thing to put together there. So you end up with x cubed, y cubed, over 1, or you can just say x cubed, y cubed. Alright, that's it for Unit 2-4. There's your chance to look at some other lessons from Dr. Berger or otherwise. You can go ahead and jot down a question for me, and we'll